Welcome everybody back to Ask Why, where we pull the curtain back on our technology and take a deeper look into what makes a capacitor. 3 weeks ago, we started a series called Capacitor Confessions, and we have looked at aluminum electrolytics, we have looked at MLCCs, and today we are going to look at film capacitors. With me here again, I got Peter Blaze, our head of technical marketing, and we're going to talk about film capacitors, where they're used, and what makes them special. So, Peter, when I start thinking about a film capacitor, of course I'm going to think about the EMI filter. But talking to you yesterday, it sounds like the film capacitors can actually be used in several different areas.
They can, but Simon, you say when you think about film capacitors, I don't think about filters at all. You know what I think about?
No.
Saran wrap.
Oh, really?
Yes, I think about saran wrap, and the reason is that saran wrap is the most commonly produced film materials in the world, and it's used for predominantly food packaging. Right.
So basically, everybody has a film capacitor at home.
Yeah, they do. And everybody has experience with saran wrap, right? Yeah. And and which we'll get to later in our discussion. So film caps are based on film material. Wouldn't be the exact same thing as saran wrap, but chemically it's polypropylene. It's the same material. It's just much more finely processed, and the structure is much better because you need really proper dielectric with it. But that's what film caps are predominantly based on. There's other variations, but today we're going to focus on polypropylene, which is the dominant material used for film caps. And film caps are used in not only EMI, but also the filtering and DC link functions of power conversion. The reason is, when you think of power conversion, on the front end, you have your EMI filtering, and you have typically X and Y safety caps, right? And they're called safety caps because they have to be UL certified. And UL has all of these tests that they put them through. And the purpose of the test is to make sure that the parts don't fail in a mechanism which can cause people to get injured, such as electrocuted, which would be a bad thing, or have the things catch fire and everybody get incinerated. Again, not a good thing at all. So the safety caps are UL certified, and the material that works best for that, again, is polypropylene film caps. So those are used on the front end, and their function in the circuitry is to basically filter out the common and differential noise that are generated by the switching components further inside the circuitry as you rectify the AC voltage. So that's their electrical function, but from a UL perspective, they're concerned about making sure people don't get accidentally injured if they fail. Once we go further into the circuit, the next stage is, we already talked about this in one of our earlier episodes, is going to be aluminum electrolytic. Those are used because they have very large cap values. We cannot get large cap values out of film because the dielectric constant is very low. And then we're going to go into the resonance stage. If it's a lower frequency resonance, for example, one of the things that's a buzzword these days in the industry is wireless charging for vehicles, right? Where, let's say you've got an electric city bus, and as it stops to drop passengers off and allow passengers to get on, you can give it a quick little oomph for battery charge through wireless charging. That is going to resonate at 85 kilohertz, which is a sweet spot for film in the resonance topology. The other area would be filtering, where in the latter stages of a power supply or power conversion, such as, say, the onboard charger of an electric vehicle, that is going to handle much higher frequencies and you're going to use bulk film cap for that function. So that is typically where film caps are used in power conversion.
So when I think about a film capacitor, we talked about the structure of an aluminum electrolytic. We talked about the structure of an MLCC. When I look at the structure of a film capacitor, what does that look like on the inside?
So again, let's go back to our starting point, which is saran wrap. So the saran wrap, a film cap would be really, if we take 2 layers of saran wrap, and each layer of saran wrap, we go and we apply a very thin amount of metal deposition. It can be, and there's different metals used depending on the application of the film cap, typically aluminum and zinc or some combination of those. And this metallization is so thin that when you hold the film up to a light, you can actually see through the metallization. That's how thin the metallization is. It's a vapor deposited metal. And the reason why this is done is you want the parts to be able to, quote, self-heal. And self-healing is where if there's a defect in the film, current flows and you literally kind of blow off that little very thin metallization in that spot and the part doesn't short out. That's one of the nice properties of film caps is they self-heal. So we take those 2 layers of saran wrap with the metallization, you offset them slightly, and then you just wrap them together. You roll them up, and then you flatten them and put them into some kind of box and fill it with epoxy. That the box and the epoxy are to environmentally protect this wound film element, but the actual capacitor piece is that wound 2 layers of film. That's the simplest structure. There's other variations. They have film foil and they have multiple layers of film and so on and so forth. But the very basic technology, the most common one would be the one I just described, which is the metallized film, 2 layers just kind of wound on top of each other.
Now, since the capacitors can kind of self-heal them, does it have a big effect on the lifetime of those types of products?
So there is a lifetime associated with film capacitors. As I mentioned, they do self-heal. When they self-heal, what is going to happen is you're slowly losing surface area of the overlapping electrodes. So when you lose surface area, you're going to lose cap. So there is going to be a degradation of capacitance over time. And as you lose surface area, your ESI is going to start to creep up. So there is a wear out mechanism of film caps. It's really a function of voltage and temperature. And the other thing too to keep in mind about film capacitors, I don't know if you've ever had experience with the microwave oven and leftovers with saran wrap on top. Have you?
I have not actually put saran wrap in the microwave, to be honest.
Oh, well, in my household, I like to, I like to have leftovers. And, you go into the fridge and you grab a leftover and you're going to put it in the microwave and you put the saran wrap over the top of it. And, what happens is that I like to just, I'm kind of, get to the end point. So I don't have a lot of finesse with warming stuff up. I just hit the high button and I just, over zap the leftover. And often what happens is it gets a little excessively hot. And when it gets excessively hot, a very funny thing happens. That saran wrap, you know what happens to that saran wrap?
Well, does it stretch or compress?
No, it actually melts.
Oh, really?
It melts, yes. And if you really overdo it, it kind of melts in your food, and then your leftover's not good anymore. But anyways, so polypropylene film actually has a melting point in the range of, I don't know, it depends on the variation of it, but 135, 145, somewhere up there, degrees Celsius. So if you get it too hot, it will melt. So when we talk about lifetime and usability of film caps, temperature is a big issue. Typically they are rated 85 degrees C up to 105, 125. There may be some that are slightly above 125 degrees C. But as you go to those elevated temperatures, their life expectancy gets reduced. So you got to pay attention to the temperature, operational temperature of the film cap, as well as the amount of current going through the part.
So now I'm based in Texas. We got solar applications, and I know they have microinverters. And those microinverters, I know there's film capacitors. So how do we deal with life expectancies and temperatures like that in Texas on solar panels?
So you're going to choose your highest rated polypropylene caps available, which they do have some that are in the 125. There may be some that are in the 135 degrees C range. That's the key thing. And then you also got to make sure that in your system, you're going to utilize effective cooling techniques to make sure that you're not going to have excessive heat building up in those components.
So it's really important to get the heat out.
You got to
So now,
get the heat out.
for design engineers watching, what would be your advice when they start using film capacitors, or when they should consider using film capacitors in the application?
So film capacitors are going to be used, again, they're the go-to for your X and Y safety caps in the front end, period. That's number 3. And then what you want to, in that area, you want to look at the temperature humidity bias rating of the parts. We produce THB 3 B level parts, which is the highest level you can get. That's an indication of how robust the parts are when exposed to excessive environmental conditions, temperature and humidity, along with applied voltage.
Is that the rating where you have the 85% humidity, 85%
Yes.
Celsius, 1,000 hours? And that,
Exactly.
Okay. Yeah, so
Exactly.
it's related to that rating.
So it's
Okay.
related to that. So that's number 1. So that's key for what's your component selection. And then in the subsequent areas of the circuitry, whether it's in the output filtering stage, or if you're using films for the DC link stage, one thing that you want to pay particular attention to, besides the life tied to the ambient temperature and the voltage you're putting on the part, one other thing which I didn't mention is you want to look at the DVDT or DIDT. That's the transition rate. As I mentioned, that film deposition you can actually see through when you hold it up to the light. It's very thin. So that makes it, if you have very high DVDTs or DIDTs, what will happen is you will actually accidentally self-heal the part, not intentionally, and start blowing off that vaporized metallization on the part. So you want to look at the specification of the part and make sure that you are not operating above the maximum DVDT or DIDT of the component.
All right. Well, you heard it here. We talked about the film capacitors today. We took a look at some examples, and we talked about some applications where you best can use film capacitors. We also took a little bit of a look of what that technology is. In Capacitor Confessions, we're really trying to dive into some of those technologies and give you guys a better understanding of what that technology is and where it can best be used. Next week, we are going to talk about the Tantalum Capacitors. And until then, keep on asking why.